Hi there. Well, congratulations on your purchase of a brand new Electrom. My name is Fabrizio Cross, and I am the inventor and probably the person you've dealt with the most in purchasing of your bike. So I guess I might as well tell you all about it and how it works. Let's start out by going over a few of the basic functions. To get onto the Electrom, we simply lift the hatch up and we step across the front of the bike and sit down into the bike. Before we close the hatch, we'll want to turn on the main power switch, and this turns on the power to the bike. The main power switch both turns on the voltage converter, which gives us all of our lights and turn signals, as well as turns on the controller. We do have the ability to turn on and off the headlight with a separate switch, which is here. And in the daytime, you may want to run with the headlight and side markers off. On the other hand, you might want to leave them on because the more visible you are, the better. Now, of course, this bike in this quite vibrant green is quite visible, but in other bikes, it might not be so. Steering is what's called an understeer. So we turn the handlebars here, and that turns the front wheel. The steering is done with a tensioned cable loop. It is very precise. It has almost no friction whatsoever, so it feels perfect. When you're steering a bike, you really don't want to feel any resistance. And it is, because it's under tension, there's no high-speed wobble or oscillation, which is also very important. Okay, let's go through the bike and the controls. On my right hand, I have the throttle, and by twisting the throttle clockwise from above, I give the bike power and move the bike forward. On my right brake controls the back brake, and this is pretty standard for bicycles. Right brake is the rear, left brake is the front. Both of your brakes will trigger the regenerative braking function as well as cut power to the controller. And this is pretty obvious why that would be. If you're coming to a stop or slowing down, you don't want to be continuing to power up the motor. So when you squeeze the brake lever a little bit, it tells the controller to turn into a generator, and it slows you down by putting power back into the battery. And as well, if you keep squeezing the brake lever, then you will actually engage the physical brakes, which means the calipers touch the rotors, and it's a hydraulic braking system. Calipers touch the rotors and they slow you down even more. So that's on my right hand side. I've got the throttle and I've got the rear brake. On my left hand side, I have the front brake and I have our turn signals. Flipping the switch down signals a right turn. Flipping the switch up signals a left turn. And then in front on the button, we have a horn. Works pretty well. And you may wish to add a bell, which I have added on my personal bike. On the other side, I have a little bell, which I can use on bike trails for more polite encounters because the horn is pretty loud. And one of the things I should probably mention about the brakes is a lot of times people have an issue if you've come to a stop and you're on an uphill and you're trying to get started and you've got the brakes locked because you don't want to roll back downhill and you're turning the throttle and nothing is happening. Well, this is because the brakes are locked and they are canceling out the controller. So the throttle, even if you have the throttle cranked all the way into full on position, there is still a gentle ramp up in the controller. So what you can do is have the brake lever squeezed in order to prevent the bike from rolling back, twist the throttle in order to tell the motor that when the brake is released, it will engage, and then you release the brake and the bike comes alive and we roll forward. Now, I stopped it before we rolled off of the center stand. Something else to mention, if you are on a steep uphill, the fact is the controllers on the Electrom are smart controllers. And when you're on the center stand, the front wheel will be off the ground. And so you can be giving it full throttle. If you're not running enough power, the motor will try to spin up to speed after a second or two, if it can't start moving, it won't do anything because it's a smart controller and it knows not to burn the controller out. So in those situations, if you're on the center stand and you're on that hill and you're waiting to get going, you've got the brake locked, you crank up the throttle, you let go of the brake and the bike starts to roll. But if it doesn't start to roll, you can use your pedals to give it a little bit of extra oomph to get off that center stand and get going. And once it does, it really gets going. So you do need to be careful. So those are our hand controls. Now I'm going to go through what's on my dash. On the dash, we have the Cycle Analyst V3, and this is a very sophisticated controller computer. This little guy actually manages both the front and the rear controller, and it handles the power levels. It actually records how much energy I'm producing when I'm pedaling. It measures speed, it measures distance. It is able to track regenerative braking functions. And in a moment, I'll go a little bit deeper into that. But for now, let's just say the Cycle Analyst is here and it's in front. One of the things to mention as well, when we hit the turn signals to go left or right, the signals are flashing. We also have reminder signals that are in the cowling, and those are there to tell us if we forget and leave the signal on, they'll hopefully remind us. That works much better in dim conditions. In the daytime, it's a little hard to see these things, so you really do have to remember, oh right, did I turn my turn signals off? This is actually a pretty common thing on motorcycles as well. Motorcycle riders just have to remember, right, turn the turn signals off. Then we've got our rear view mirrors, and these are easily adjustable to suit your height and your everything else. Works pretty well. Let's go onwards through the rest of the bike. Here are our pedals. Their use is obvious. One thing to mention about the pedals though, when you are pedaling, you are connected to the back wheel via chain that's running along here. And so you cannot just pedal and produce electricity if you're sitting in a standstill because you're still connected to the back wheel. As soon as you're over about 10 kilometers per hour, then that chain line to the back wheel is just freewheeling. As it would on a normal bike, if you were going faster than the gearing you had allowed, then your back would just be, you could be spinning your pedals, but nothing would be happening. In the case of the Electrom, what is happening is that excess energy that you're producing is going into the generator and producing electricity, which is great. And you may have noticed when I was talking about the controls, the one thing I didn't talk about was a gear shifter, because there are none. The generator chain drive effectively acts like an automatic transmission for the Electrom, so you won't need to shift a bunch of gears. The seat on the Electrom has actually been made custom for the Electrom, made by me in fact, and designed by me. We have a very comfortable seat cushion, and this is fine tunable. You can actually add extra padding by taking off the cover and adding a bit if you wish, but it's actually pretty good as it is. And it just sits in a slot. It has no reason to go anywhere, but we haven't fastened it down because if you park your Electrom in the rain, one of the things you'll want to do is take your seat off and drop it into the tail box so that it doesn't get wet. Then when you come back, you can pick up your seat and put it back on the bike. Something else to talk about the seat, it has adjustments. It is held down by 4 bolts, and those bolts are in a slot. So you can loosen off the bolts and slide the seat fore and aft by a couple of inches for minor adjustments. And then should you need to, you can undo the bolts entirely and move the bolts to new holes for larger adjustments. The seat has about 12 inches in total of fore and aft adjustment. So the bike actually accommodates quite a large range of people. As well, the seat is a carbon fiber frame with a mesh back. And we've done this for a very specific reason. If you're sitting up against a non-breathing seat back while you're exercising, you get a really sweaty back. So the mesh back allows for air ventilation and allows you to not get quite so hot. As well, the mesh back is held on by 5 straps that range up and down the bike. And by tensioning and loosening these straps, you can fine-tune the feel and the form of the seat to fit your particular torso type. Some people have a wider midsection, some people want a little more depth in the shoulders, and the nice thing about the Electrom seat is you can fine-tune it for your body shape. And as well, of course, you can move it fore and aft to match your leg length. Put the seat back here. As we work our way back, the Electrom hatch on the tail box opens and closes. We have a locking hatch lid, so you can use the keys that are supplied with the bike to lock the hatch. I should point out, of course, that just like that old axiom, locks keep honest people honest. So if somebody really wants to break into your Electrom tail box, it has to be lightweight in order for the bike to work. It's made out of carbon fiber. If somebody really wants to break in here, they're going to be able to reef in here and get it, whatever you've got in there. So I highly recommend you don't store anything super valuable in there. However, it's a nice place to put your seat or your helmet. And if you're just going out grocery shopping, then you can drop your groceries in there, and people are very unlikely to steal your groceries. The hatch opens and it can be held up in place just by little Velcro tabs here. We looked around for lots of different ways to do it, and in the end, the Velcro is the simplest and lightest way to do it. And then you just pull it back down to close it. In order to remove the hatch to carry bigger passengers, to carry passengers or to carry larger cargo, we simply slide the hatch sideways, and it is mounted by removable pin hinges. To put it back on, we line up the pin hinges and close it back down. Okay, so those are the basic functions of the bike. Now let's get a little bit more in depth on the Cycle Analyst V3, as I think there's some important things that you'll need to know about how this works. I'll just climb onto the bike, and then we can start talking about it from the seat. Okay, so here we are looking at the Cycle Analyst V3, and there are a bunch of functions on this. I'm only going to go over some of the most important as they pertain to the Electrom. But if you want to find out more, you can always find out more at the Grin Technology site. They are the manufacturer of the Cycle Analyst V3. And now, what's important? How to change your power settings. If I hold the left button and then press the right button, it will take me through my 3 preset power settings. Very important to remember. If you hold the right button if you hold the left button for too long by itself, you will enter the setup menu. And this allows you to actually adjust all the settings on the Cycle Analyst. I recommend that you do not mess with the settings until you really know what you're doing. So if you accidentally go into setup menu, just press and hold the button again, and you will exit, leave setup, and go back into the regular screen. So to change your power settings, press and hold the left button, and then quickly press the right button to move through. So pressing and holding, and I'm pressing the right button to move through our mode presets. And each bike is going to have different mode presets, but mode preset 1 is what the bike will always flash up in. And depending on where you live, your Electrom will be shipped to you so that mode 1 is your e-bike legal maximum for your area. So it'll be your e-bike legal maximum speed and your e-bike legal maximum power. Then typically mode 2, go to mode 2. Mode 2 is your day-to-day driving setting. Because the fact is, the Electrom is a big, heavy bike. It actually needs a lot more power, or a little bit more power, let's say, than a lot of jurisdictions legally allow. Now, I should say that you should only go to mode 2 in an off-road setting where you are not breaking any laws. That said, when you're in mode 2, you will typically be set up to draw between 2,000 and 2,500 watts, and your maximum speed will be typically about 40 to 45 kilometers per hour. In the United States, the speed pedelec, like say for example in the state of California, the speed pedelec top speed allows for a top speed of 28 miles per hour, which is, I believe, 42 kilometers per hour. And most United States allow a top wattage draw of 750 watts. So your mode 1 will be set up for that. Your mode 2 will be set up to draw about 2,000 watts, which, while a little bit more powerful than is legally allowable, is still quite efficient. Now, if we go to mode 3 is basically your unlimited power setting. This allows for the maximum speed that the bike can deliver and the maximum power that the Cycle Analyst will allow to the rear controller. And the reason I say the maximum power the Cycle Analyst will allow to the rear controller is because, once again, if you're drawing that power all the time and you've heated up the rear motor, the Cycle Analyst is going to start to limit the amount of power that's allowed to go to the rear. And then if we press and hold again, we go back to mode 1. Okay, here we are seated down and we're looking at the Cycle Analyst V3. This is the computer that controls the whole bike. As well, it tells us everything we need to know about what's going on. Now, let's go through the screen, the first screen first. When you first flash up the bike, you will be in your lowest power setting. It automatically defaults this way. And this is handy because, say, for example, if you get pulled over by the police, you can always just turn the power off and back on again, and you will be in your e-bike legal setting for your jurisdiction. Let's go through the screen, working our way from left to right. This little battery indicator is a rough indicator of how much battery we have left. And this is our voltage, and you can see that it flashes between voltage and amp hours. I have just reset the amp hours, and typically what you do is you reset the amp hours each time you charge the bike. The bicycle has a 40 amp hour battery pack, and this measurement here tells you how many amp hours you've pulled out of the pack. That is the most accurate way to know how much power you have left. However, you do have to remember to reset the Cycle Analyst when you charge so that it knows it's starting from a full charge. The voltage is a fairly decent indicator of how much rough power you have. However, when you're drawing a lot of power, that voltage number is going to sag. So it's only a good indicator when it's sitting and not actually drawing any power of roughly how much power is in the battery. Now, this is a 72 volt nominal system, and what that means is 72 volts is the middle average voltage of the battery, halfway between fully discharged and fully charged. This battery pack, fully discharged, it shuts down at 60 volts, and fully charged, it sits at 84 volts. So 72 or 73 volts is kind of right about in the middle. This next screen down here is how many watts we are drawing as we are riding. And you can see if I just give it a little bit of throttle, but it's not actually able to go anywhere, you can see that wattage number is going up, and I've released the throttle, it's gone back down. So this gives you an idea of how much power you're drawing in the moment. This has all been zeroed out, but over here on the upper right, we have the solar watts and the kilometers covered. And if you're in the United States, that will be solar watts and miles covered. Now, solar watts is something we've co-opted. The Cycle Analyst is designed for solar bike racing, and it has the ability to measure how much power your solar panel is producing. We're using that function to measure how much power the human being is producing through the generator chain drive system. So if I was pedaling, this number would show me how many watts are being produced. And in fact, let's take a break, and I'm going to put the rear bike up on a stand so we can actually have a look at some of those numbers. Okay, So now I've got the bike up on a stand and we can see what's actually happening here. So when I start pedaling, we will see this number when it comes back. I'm producing about 150 to 170 watts of power. Now, as you can tell, it's pretty noisy. And I'm going at about 10 kilometers per hour because I'm using the chain to drive the rear wheel. Now, if I twist the throttle, you can see we are now going 40 kilometers per hour and still producing our wattage. And you can see that we're not working against any resistance, so the motor's only drawing about 100 watts in order to move the bike, but we're not actually moving anywhere because the wheel is off the ground. Now I'm going to stop pedaling now so I can talk because it's a lot of work to produce 150 watts. As we work our way down, we're kind of going clockwise on this thing. This number here is our kilometers per hour. So if I grab the throttle and bring it up to speed, we're now going 32 kilometers per hour. And as I said, if you were in the United States, we'll switch this over to miles per hour. And this flashing indicates that the bike has a limit on it and you've reached the limit. And currently the limit here I have set for 40 kilometers per hour. So it's surging up and down and just trying to keep the speed at about 40 kilometers per hour. If I hit the brake, it comes to a stop. We saw a brief flash of a negative number. That is because when we start producing power to put back in the battery through regenerative braking, this power used number goes negative. Now, let's see if I can show you that while pedaling. So I've got the brake lever squeezed and I'm pedaling. So I'm actually using the rear motor to produce power. And this is how much I'm producing through the rear motor. It's very hard to pedal this way, but if you were actually on the road, then you would be slowing the bike down. Working our way along here, this little signal here is both our throttle indicator. If I'm not using the brakes, we just have a line. And if I twist the throttle, then this little dot goes up. I'm applying more throttle. So this basically tells us where the throttle is. And now we're fully wide open. But because we have a limiter, we're seeing this flashing number and our maximum speed. If I squeeze the brake lever, the symbol turns into a brake lever symbol and it tells us that the brake is applied. Now, this is actually a pretty handy reminder. If you're sitting there and you've got the brake on and you forget about the fact that the brake canceled out the throttle, you're sitting there, the brake is on and you're turning the throttle and nothing's happening. Hopefully this little symbol will help you remember that you're not moving anywhere because your brake is on. Now, this Cycle Analyst V3 has a lot of screens. I'm just going to briefly go through them, but as I said, you should probably double check on the Grin Technologies website and really learn how this thing works. We move forward and backward through the screens with the left and right buttons. And so I press the right button and I go forward this way. This screen is a more accurate depiction of power and solar wattage. So it doesn't flash back and forth. Now it just sits there. But the one thing about this screen is it doesn't show us our speed. So I tend to stay on the main screen. The next screen is going to tell us other information. This is our kilometers per hour. If we were running a cadence sensor, this would tell us our RPM. I'm not going to go too deep into these screens because a lot of this stuff is really much deeper than it need to be. We see our voltage there. This one, screen number 3, is kind of handy. It's telling us how many watt hours we have gone through and how many solar watt hours or human hours, watt hours we have produced. It's going back and forth there. And as well, on this side, we're telling our watt hours per kilometer as well as our net watt hours per kilometer. And what that is The watt hours per kilometer is how many watt hours, and if once again in the United States it would be watt hours per mile, it's how many watt hours per mile you are expending at your current rate. The net watt hours per kilometer or per mile is once you subtract the human energy that you're reproducing and the energy you've gotten back from regenerative braking from your stopping and starting, it's telling you how many watt hours you're actually consuming. One thing I should point out, the Cycle Analyst is not measuring the power that's being drawn by the lights. So you are actually drawing a little bit more power than this is recording. The headlight is a 30 watt headlight. So the Cycle Analyst is not measuring that. However, I should point out that you would use 30 watts climbing a hill. You would use 30 watts in about 2 seconds. So it's not a super big deal that we're not recording how much power the lights are drawing, because it's so tiny compared to how much power the motor system is drawing. And clicking through the screens now, there's a whole bunch of other screens which will tell us. So this is our solar percentage. This is our regen percentage. These numbers are very inaccurate because I'm up on a stand. So of course it thinks we've produced a huge amount of power through regen and a huge amount of power through solar. But the fact is we haven't, or we have, but in a real world situation, these numbers would be very different. In stop and go city driving, typically regen power is usually about 15%. And out on the highway, I find it averages about 7%. And then with solar, it's really a function of what power I'm drawing. So if I'm in my lowest power setting and going quite slow, then my solar percentage, as in the percentage of power that the human being is contributing, can be as high as about 25%. But the reality is, most of the time, if I'm going faster and climbing a lot of hills, that solar percentage is usually between 5 and 10%. You really do want to think of the Electrom as an exercise bike that happens to move. It's really not about how efficiently you're using the human power. It's about the quality of exercise you get and the fact that you can put some power back into the bike. And working our way through, this is the amp minimum, amp maximum. These are settings that basically, or these are numbers that tell you more about power consumption. The next screen, I'm clicking along here. This is my maximum speed, average speed, and how many hours and minutes and seconds the system has been running. And it only accumulates time if I'm actually moving. So when we stop, it stops accumulating time. This screen is important. So I've just clicked again. This is screen number 7, I think. And once again, please do go consult the Grin Technologies website. Here is a link. Do consult the Grin Technologies website to learn more about the Cycle Analyst. But this screen is important. This is T now, and the T stands for temperature. And this is the temperature of the rear motor, which is the more powerful motor and the one that is more likely to heat up. And there's temperature now, temperature max, and temperature average. If you're running in a really high power setting, like say, for example, you're allowing the motor to draw the maximum power that its controller will put out, that is in the neighborhood of about 4,000 watts. That is very high power, and that, especially in a warm climate, will heat that motor up quite quickly. And the reality is that you really don't want to be drawing that much power all the time anyway, because you're going to run your battery down much faster, and it's just not a very efficient thing to do. But it's not unusual for the running temperature, especially on a warm day, and if you're running at about the 2,000 watt average, it's not unusual for the temperature to be hovering around 70 or 80. And this, by the way, is in Celsius. I don't know if it switches to Fahrenheit when you switch to miles per hour. That's something I'll have to find out, I guess. But what I can tell you is when the motor gets up around 100 degrees Celsius, the controller starts to cut back power to the motor in order to limit the motor temperature and prevent the motor from overheating. And so this is a safety function. It's great because it will protect you from destroying your motor by running too high a power, but it does mean that if you're insisting on running super high power and climbing lots of hills all the time, then this might not be the bike for you. However, I have found most people don't have an issue with this. When the only time I have ran into a situation where it was overheating and causing me problems was when I was testing the Electrom by climbing a ski hill, and I was going up and down it multiple times. I was doing speed runs, and what do you know, it was a very hot day. It was 40 degrees Celsius, which is in the neighborhood of 100 degrees Fahrenheit. And so what do you know, the motor was getting too hot and it was limiting power. It's only ever happened to me once. Very uncommon situation because I was climbing a ski hill over and over and over again. Not a normal thing. Next screen is our trip kilometers, and this is resettable, and I'll show you how to set that eventually. And this is our total kilometers. So this bike has 168 kilometers on it. It's a brand new bike. It's going to a customer in California, and I like to do a lot of testing on the bikes before I send them off because the Electrom is a new product, and I like to make very, very certain that we're not going to run into problems for those customers later down the road. And this is the resistance in our batteries and the number of cycles, and this battery has been charged and discharged twice. This is actually kind of a handy screen. This tells us what our throttle is set at, and this is what the power is actually being put out. Something to remember about the Cycle Analyst is it's actually taking all of our inputs. It's taking our signal from our brakes, and it is taking our signal from the throttle and modifying that because of the settings we've given it. So if we say, I only want to draw a maximum of 2000 watts, then we crank the throttle all the way up. The Cycle Analyst will then modify the throttle out signal that it sends to the controllers to make sure that the controllers draw a maximum of 2000 watts. So the in, and this is only important from a diagnostic point of view, if you're trying to figure out if there's something odd going on with your bike. In is your throttle in signal. How much, what is your throttle set at? And maximum throttle, you can see the in is 40.23 volts. The maximum in is 4.23 volts. But you see over here that it's only putting out about 1.5 volts. And the reason for this is because we have, I'm going to turn that off so we can speak properly. Because we have a maximum speed set on this, and I'm up off of the ground, there's no resistance. It's not having to really put any power in at all to keep that maximum speed going. So it's choking back on the out throttle signal in order to maintain what we've asked, which is a maximum speed of 40 kilometers per hour. I know this is a lot to think about, and probably it sounds like gobbledygook. Over time, this will make more sense, and you can reconsult this video, and as well, the Grin Technologies website will tell you a lot, and you can read through over time, and it will make more sense. And one more click, and we're back to the main screen. So that is a brief tour of the Cycle Analyst. I apologize for the gobbledygook. I promise it will make more sense soon.